Stephanie from Osmosis Pharmacy Test Prep, and today we're going to talk about a milliequivalent problem. So these problems look very intimidating on the exam. They give lots of information and it looks really complicated, and you're going to want to skip these problems, or at least that'll be your first instinct. But we're going to give you the confidence so that you can answer these questions and be sure that you're getting the correct answer. Often these are one-step conversions. There's just several of them within the problem, so they're really just one-step problems. There's just several of them that you need to do to get the correct answer. So whenever you see these problems, don't feel intimidated. We're going to go step by step and show you how to answer these questions, okay? So the question says, what is the final volume needed to make a TPN with the following electrolytes? So what a TPN is, it's total parenteral nutrition. So this is a bag that is hung whenever you're in the hospital as a patient, and it's your total daily nutrition in one bag. So these are patients who can't take medicines by mouth, and they're using this to get the electrolytes that they need to sustain life. And with this, they have to be calculated by the pharmacy. You're going to be given lots of information in the problem. This is not information that you are required to know. So don't feel like that is going to be needed. It's really just knowing how to get the step-by-step approach to get the correct answer. That's what you're going to need to be able to know how to do with this problem. All right, so lots of information is given. So this is the amount of each of, there are 8 different electrolytes in this TPN. And in the problem, they give you the amount of milliequivalents that are needed of the electrolytes. That's a common unit of measurement for electrolytes. And then they also give you the concentrations of the vials of electrolytes that you're going to add to the TPN. So they're going to give you both the concentration of the electrolytes and the amount of milliequivalents that are needed. And then you are to calculate, by adding each of these 8 electrolytes, the volume that's needed of each of these to get the correct answer. All right, so we're going to start with the first problem, and we're going to set these up as a factor labeling problem. The main thing on these is to stay organized on your page so that you know which electrolyte strength is needed with which conversion. So you want to make sure that those are matched up together. So we're going to start with sodium chloride. And so 50 milliequivalents. And so since milliequivalents on top, we need the milliequivalents on the bottom. So we're going to look at our concentration. And to convert milliequivalents to milliliters, there are 4 milliequivalents in 1 milliliter. Okay. So then you just multiply by the items on top and divide by the items on bottom. So 50 divided by 4, and that comes to 12.5 milliliters of sodium chloride. All right, the next item is sodium phosphate. So we're going to look up here. We need 30 milliequivalents of this. And again, we need to convert milliequivalents to milliliters. So we're going to look at our concentration here. And it also has 4 milliequivalents per mil. So then multiplying by what's on top and dividing by what's on bottom, 30 divided by 4, that comes to 7.5 milliliters. And that is sodium phosphate. Next is potassium acetate. So you can see in this problem up here, we need 15 milliequivalents. And our conversion is given here. There are 2 milliequivalents per mil. So 15 divided by 2, so that also comes to 7.5 mils. And that is potassium acetate. And the next one is magnesium sulfate. So that's 10 milliequivalents. And the conversion here that's given is 4 milliequivalents. So multiply by what's on top, divide by what's on bottom. So 10 divided by 4, so that gives us 2.5 mils, and that is magnesium sulfate. All right, next up is sodium acetate. So at the top we have 10 milliequivalents. and we're given our conversion of 2 milliequivalents for every mil. So we're going to multiply by what's on top and divide by what's on bottom. So 10 divided by 2 is going to be 5 milliliters of this is sodium acetate. Next up is potassium chloride. So we've got 100 milliequivalents. And in the problem, we're told that 2 milliequivalents is in every mil. So multiply by what's on top, divide by what's on bottom. 100 divided by 2, so that's 50 milliliters of potassium chloride. All right, the next electrolyte is potassium phosphate. So from the problem up here, it shows that we have 20 milliequivalents that are needed of that electrolyte. And the conversion here is 4.4 milliequivalent per 1 ml. And so that gives us 4.5 milliliters of potassium phosphate. Okay. And then our last electrolyte is the calcium gluconate, and we need 10 milliequivalents. And the conversion given is 0.645 milliequivalents per 1 ml. And so when you multiply that out, the answer comes to 15.5 mLs. All right, so this is lots and lots of one-step calculations. But to get the final answer, all we need to do is just add all of the quantities, the milliliters of electrolytes, and that will give us the final volume of electrolytes that are needed to the final volume needed to make the TPN. All right, so we're going to do 12.5 ml of sodium chloride, 7.5 ml of sodium phosphate, 7.5 ml of potassium acetate, 2.5 ml of magnesium sulfate, 5 ml sodium acetate, 50 ml potassium chloride, 4.5 ml of potassium phosphate, and 15.5 ml of calcium gluconate. All right, so whenever you add all of these quantities together, that total comes to 105 ml. And when you look up at the answers, that is B, which is 105 ml. Like I said, these look like really complicated problems, but they are just one-step conversions, and then you just add your quantities together. Another thing that you would want to do whenever you see a problem like this is sometimes they will give you all of this information in the problem, and then they'll just ask you for how many milliliters are needed for sodium acetate. So you wouldn't necessarily need to do all of these conversions and calculate the final volume. They may just want to know what this single conversion is for that single electrolyte that's needed. So just be sure to read your questions carefully so that you're not doing a whole lot of extra work to get the correct answer for the problem whenever they ask it. And again, thank you for choosing Osmosis Pharmacy Test Prep.